So let's start with a simple cost model so that we can begin our analysis. The basic variables in this cost model are just three. The letter B is the number of data blocks in the file. So in the picture to the right, you can see it's got B blocks. The letter R is the number of records per block. And as you'll see, we've already got our first assumption now, which is that R is the same on every block. Okay, so we're assuming that every block holds the same number of records. And D is the average time to read or write a disk block. Here's another assumption. D is being said to be just one value. It's average. So we're not going to make a distinction between sequential access for near blocks and remote access or random access across randomly placed blocks. So those are big assumptions that we're making up front, but let's be clear about them and we'll work with them. You can enrich this cost model to take more care to think about a distribution of the number of records per block, for example. You could take more care to distinguish random versus sequential IOs, but we're not going to do that today. All right, our focus is going to be this average case analysis for a fairly uniform random workload. So a workload where the requests are going to come in randomly for different things. And we are going to ignore, as I said, sequential versus random I/O. We're going to ignore prefetching, so we're not going to assume that the I/O layer will be smart enough to fetch ahead of our requests. We're also going to ignore any in-memory costs, so we'll assume that anything that doesn't touch a disk is free. So all our CPU costs for computing offsets and copying and moving things, we will assume are free. Now these are not good assumptions in full detail, but they're good enough to show us the overall trends today. And as I said, I encourage you to go back to this lecture, put in better assumptions, and come up with better estimates for the costs. Okay, here are some more assumptions. First of all, and this is a big assumption, we'll assume that every insert and every delete query is an insert or delete of a single record. In practice, that might not be true. For today, we're going to do that to simplify our calculations. For equality selections, we'll assume exactly one match for a selection of the form where column equals value. Now, obviously, in general, that wouldn't be true. If you say where name equals Joe, for example, there might be many matches in a data set. But we'll assume here that there's going to be exactly one match for each equality selection. It's a strong assumption, but again, we'll use it to simplify our calculations. For heap files, we're going to assume that insertions always append to the end of the file, to the last block of the file in the last empty slot of that block. Again, that's not necessarily going to happen in practice. We'll assume it happens today for our analysis. Now for sorted files, we're going to assume that we're going to maintain them packed, which means that after a deletion, we're going to compact the file so that it has no holes. These sorted files are going to be sorted according to some search key, which you can think of as a particular column that we want to sort on. So here's the extra challenge to you as a student. After understanding these slides with all the assumptions I just made to simplify things, you should question those assumptions. Okay? If you don't like one of those assumptions, great. Why don't you replace it with a less restrictive assumption, a more reasonable assumption, and then rework the remaining slides to get the costs refined. This is a great way to understand if you really know what's going on in the class. It's a great way to exercise and study for test. It's also a good way to generate ideas for new kinds of techniques and new kinds of optimizations, because in future hardware may change, for example, or workloads may change. And if you've anticipated that with a good cost model, you may invent a technique that's appropriate for the scenarios that we'll see in the future.